Hey guys, Tomatho here. Here is a tricky and challenging algebra problem. Can you solve it? Here is the problem statement. Find the sum of all possible real numbers x such that the following equation holds. Here are some hints for this question. You can pause at this point if you would like to give it a try, and as usual, the latter hints will be closer to the actual answer. So first, can you notice any other relationship among the three terms in the expression? Maybe you can consider ignore the cube first. Next, try add the two terms on the left hand side. What do you notice? So, let us expand each of the cubic terms to solve it, right? Wait, but that would be very complicated and long-winded. Well, if that's the case, what should we do then? Let us take a closer look at the three terms from the problem. And actually, notice that if we ignore the cube, this equation still holds because, as you can see, if we add them, 3 to the power of x minus 9 plus 9 to the power of x minus 81 is equals to the right hand side, which is 9 to the power of x plus 3 to the power of x minus 90. So to simplify the problem, we can assume both terms on the left hand side as a and b. Thus, right hand side becomes a plus b. So if we rewrite the original equation, we have a cubed plus b cubed equals to a plus b cubed. Expanding the right hand side, we have as follows: a cubed plus 3a squared b plus 3ab squared plus b cubed. And then, cancelling out the common terms, we have 3a squared b plus 3ab squared equals to 0. Then, simplifying it and factorizing it, we have a times b times a plus b equals to 0. Wow! See? Look at how simple the problem now is. Since it is a product of three terms that gives 0, we only have these three possible cases. Case 1, when a equals to 0. Case 2, when b equals to 0. The first case is 3 to the power of x minus 9 equals to 0. And simplifying it, we have 3 to the power of x equals to 9, which gives x equals to 2. Similarly, for the case when b equals to 0, we have 9 to the power of x equals to 81, which gives x equals 2. And lastly, for case 3, a plus b equals to 0, this gives 9 to the power of x plus 3 to the power of x minus 90 equals to 0. We know that 9 to the power of x can be rewrite as 3 to the power of x squared. So we can rewrite it as follows. And this is a familiar quadratic equation that we know. So with simple factorization, we have 3 to the power of x plus 10 times 3 to the power of x minus 9 equals to 0. This gives us two cases: 3 to the power of x equals to minus 10 or 3 to the power of x equals to 9. Well, clearly, since x is a real number, 3 to the power of x is always positive. Thus, the only possible case is that 3 to the power of x equals to 9. And this also gives x equals to 2. So, we can conclude from case 1, case 2, and case 3, the only possible value for x that satisfies the condition is 2, and therefore the sum of all real number x is 2. So yeah, finally we get our answer. It's 2. See, this problem looks challenging, but once you know the trick, it becomes very simple, right? Let me know in the comment section if you get the answer. Thank you for watching. Give a thumbs up if you like this video and subscribe to my channel if you would like to see more interesting math video.